Well, hello, students. You know, we've been at this with Mr. Rafferty's Naturehood for a whole year now. Here we are, back at spring again. And there's a lot of really cool things springing up in the forest that I'd love to show you. And I will. But you know, in order for that growth to occur, there had to be plants and animals and other organisms that died along the way. And I thought today would be also a good day to pay our respects to some of those creatures that have passed away, and also to all the organisms that are out there helping to recycle those nutrients. You know, when an organism passes away, its nutrients, especially phosphorus and nitrogen, get returned to the soil. And those are important nutrients for the new plants to take up. So let's just have a moment of silence for all the organisms that have left us this past year. Let's observe a moment of silence. Here we are. You know, last year I noticed that someone had thrown an old jack-o'-lantern out in the field here, and I thought it'd be fun to see what it looks like this spring. I can still make out a little bit of the skin. Here's where the stem was, but most of it is soft like pumpkin pie. In a month or so, this will all be in the ground. The nutrients will be taken up by the plants around it. Let's have a closer look. I'll set my super sophisticated binoculars on microscopic view at 1000 power. Beep, 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 beep. Here we go. Let's see what we can see. I'm seeing hyphae growing through the pumpkin. As they grow, they release enzymes that help digest it. And there are 3 types of bacteria. Let's take a look. Spherical, spiral, and even some rod-shaped bacteria, all working in decomposing this.
These bacteria and fungi are important decomposers, helping to return the nutrients of dead organisms back to the soil. But there are other decomposers that are also important. These are the macroinvertebrates. Macro meaning large. These invertebrates can be easily seen without magnification. This is a time lapse of decomposers working on a pile of leaves. On the left-hand side, there are only bacteria and fungi, while the right-hand side includes macroinvertebrates. You can see how much more efficiently they recycle the nutrients into the soil. In fact, sometimes they're too efficient. Earthworms are considered an invasive species in Minnesota. The leaves on the forest floor provide a protective layer for the little plants coming up in the spring. Plus, the leaves are their own little habitat for many small creatures, and these small creatures are an important part of the food chain in the forest ecosystem.
Soil is a complex mixture of biotic and abiotic things. So we have the top layer, which is where all the decomposition is happening, the breaking down of the organic matter as it becomes part of the soil. And then you have a darker layer of the soil, which is called the topsoil. So in this area is where almost all of the nutrients are. So nutrients aren't food. So when you buy fertilizer for your plants, and people call it plant food,
It's really nutrients. Nutrients are building blocks that are needed for very specific molecules that the plant needs. Food is actually the sugars that the plant makes from photosynthesis. Speaking of food, I'm a little hungry. I think I'll get a little potassium from this banana. When we harvest crops off the land from a garden or a farm, we're removing the nutrients that are locked up in the plant and the waste products. So with this banana peel, I have a few options. I could, or I could do organics recycling. What is organics recycling? Well, let's find out together.
Recycling is the process of collecting biodegradable organic material, like food scraps and some types of paper waste, and turning them into compost. You've probably heard the term compost, but do you know what it actually is? Compost is an end product of organics recycling. It's an extremely nutrient-rich soil created by the controlled breakdown of organic material. This makes it a super effective fertilizer for growing plants.
For my guest expert today, I only had to look as far as the 2010 Woodbury Middle School yearbook.
My name is Marielle Mateo, and I am a Green Corps member serving Hennepin County's Waste Reduction and Recycling Unit. I also work as a junior researcher for a consultant with the DNR, or Department of Natural Resources, and I will be assisting their aquatic invasive species program. I graduated from Woodbury High School, and I went to Woodbury Middle School as well, and I went to the University of Minnesota Twin Cities, where I got a degree in fisheries, wildlife, and conservation biology, and a minor in environmental science, policy, and management. And while I was at the University of Minnesota, I was part of the recycling program there, and so I helped set up zero waste events, as well as help roll out the organics recycling program that's currently at the University of Minnesota. Recycling organic matter is extremely important for the environment. So studies have shown that at least 25% of our trash is, by weight, organic matter. Majority, it's food. So it could be moldy food or edible food. In fact, 30% of all of the food that we produce in the United States ends up getting thrown away. And so all the food, as well as all the labor, the water, the fertilizer, the land, and energy that went into producing that food is going to waste. So from the environmental lens, you may ask, well, it's food / organic matter, it's gonna break down in a landfill. This actually isn't the case. Landfills weren't created to efficiently break down the items within them. Landfills were actually made to lock away these items in an anaerobic environment. And so an anaerobic environment, or an environment without oxygen, isn't very good for microorganisms to break down food. And so what ends up happening is that the food / organic matter breaks down really, really slowly. And this releases a lot more methane than carbon dioxide. And methane is a greenhouse gas. And it's actually far more potent and better at trapping heat than carbon dioxide is. And so it's really important to take that organic matter and compost it instead, which produces significantly less methane, and you have a useful product at the end of it. You get compost. In Minneapolis, they have an organics recycling program, which means along with your recycling and trash cart, you get a smaller organics cart. And so you can put your food scraps in it as long as it's in a paper bag or a compostable bag. And those carts are then taken to an industrial composting facility. At an industrial composting facility, food scraps, yard waste, and compostable plastics are put in a pile together and then screened for contaminants. Once they are screened, they are put into these large piles to break down further. And these piles can be as tall as 10 feet and can get up to 160 degrees Fahrenheit for internal temperature. And that's from all the microbial action that's happening within them. This microbial action is also extremely important because part of the procedure of creating this compost is making sure that it gets up to a temperature of 130 degrees for 7 consecutive days. And so that is to kill off any harmful bacteria such as E. coli or Salmonella, as well as kill any invasive species seeds that might have come in from the yard waste. You can get your backyard pile to a certain size and volume that you could potentially reach the temperature of 130, but it's more likely going to stick around the temperatures of 90 to 120 degrees, as well as fluctuate based on the weather. And so it's less likely that you'll be able to kill off invasive species within your compost pile. So backyard composting is going to be a little bit different from industrial composting in that you probably don't want to put in the same things that you would into an organics recycling cart. So for example, you want to skip dairy or meats, in part because they can attract wildlife to your compost pile and mess it up, as well as they can harbor dangerous pathogens such as Salmonella or E. coli. I think it must have been my junior year of college. I was able to have the opportunity to be a student worker for the Department of Natural Resources Aquatic Invasive Species Program. And so this meant I got the perfect world of an even split of office work and field work. And so in the summer, I would go out with the aquatic invasive carp crew, the aquatic invasive plant crew, and be able to see these amazing things out on the water, as well as survey where there are invasive plants so we can help lakeside property owners in helping develop a plan of management for these invasive species. Because a lot of the times these invasive plant species can overrun the entire lake and make it difficult to boat around there because they get so caught into motors and propellers of boats. I'd say going out with the aquatic invasive carp crew was some of the most fun times I've had, because we just got to see these amazing river fish like the sturgeon in that picture, as well as would see these giant river catfish and just other amazing fish that I would probably have never seen otherwise. I actually don't fish or do much water recreation, and so I got to see these amazing animals, as well as just experience what it's like to be a Department of Natural Resources fish biologist.
For today's outdoor adventure, we're heading over to the city of Minneapolis to Eloise Butler Wildflower Garden and Bird Sanctuary. Our first stop is the Upland Prairie. As you can see, they've recently burned off the dead vegetation. All of this ash on the ground here is packed with nutrients that will return to the soil: phosphorus, nitrogen, potassium, and calcium. Heading into the forest, it's a great time for spring wildflowers. The strategy these plants have evolved is to come up early before there's any leaves on the trees. They have no competition for the sunlight, and they're the first plants to soak up the nutrients from all of the organisms that passed away the year before. Woodland wildflower's strategy is to live fast and die young, although in this case, only the top part of the plant dies back. After a couple of months of quick growth, photosynthesis, and flowering, these plants will send their extra nutrients down into the ground into thick root structures, where they store their energy until next year. Many of these beautiful wildflowers are labeled with both the common name and the scientific name. The scientific name, genus and species, is often descriptive of the plant. Wouldn't it be great if there was a Latin teacher who could explain these scientific names to us? Fortunately, thanks to the latest technology, I did have a Latin teacher with me. Introducing the Pocket Latin Teacher. Pocket Latin Teacher is based on the famous Central High Latin teacher, Mr. Rick Ley, standing only 5 inches tall, perfect for those outdoor adventures where you just need a Latin teacher. Pocket Latin Teacher is also fully water resistant. The newest version of the Pocket Latin Teacher comes with a full Greek dictionary, making it perfect for those pesky scientific names that use both Greek and Latin root words. If the Latin teacher becomes overexcited, as it's prone to do, simply tap once to pause and twice for sleep mode.
Well, palustrous means marshy or swampy. Sanguinaria, so that comes from the Latin word for blood, sanguis sanguinis. Dye comes from Sanskrit, which means double or inseparable, and then the Greeks and the Romans also use it.
So what were the themes of this week's episode? Well, we learned that there is a circle of life, that when things die in nature, they're not wasted. All the energy that's locked up inside the organism is used by the environment, either by scavengers or decomposers feeding on them. And the decomposers recycle the nutrients, particularly things like potassium, nitrogen, and phosphorus. Those are then returned to the soil, and that soil becomes more fertile. When we remove material from a landscape, we're robbing the soil of those future nutrients. So we either have to fertilize or use compost. Until next time, have a beautiful day.
Everybody is wondering what and where they all came from. Everybody is worrying about where they're gonna go when the whole thing's done. But no one knows for certain, and so it's all the same to me. I think I'll just let the mystery be. Some say once gone, you're gone forever, and some say you're gonna come back. Some say you rest in the arms of the Savior if in sinful ways you lack. Some say that they're coming back in a garden, bunch of carrots and little sweets. I think I'll just let the mystery be.
You just remember what your past said, or you got a friend in